example 2. Let's look at 2a. And what we're going to do is evaluate these expressions. So the way to do this is to, think about the fact that when you are simplifying a logarithm, you're really trying to identify the exponent. All right, so what this is saying is, what's my base here? My base is 3, and it's saying, what power do I raise 3 to in order to get to 81? Well, I know that 3 to the 4th is 81, right? 9 times 9, right? So that means the answer to a logarithm is the exponent. So that means the answer to this, or the simple, when I simplify this expression, I'm going to get 4. All right, let's look at B. This says, okay, log base 5 of 0.04. Okay, this one's just a little bit trickier because you're looking at 0.4 and you're kind of like, how do I raise 5 to that power to get 0.4? But let's think about what this decimal is when I think about it in terms of a fraction. Well, that's the same thing as saying 4 over 100, right? It's 4 100ths. Okay, and what is this if I simplify this? That's 1 over 25. So I'm saying, what power would I raise 5 to? What exponent would I raise 5 to in order to get to 1/25th? Well, I'd have to raise it to the -2 power, right? So this simplifies out to -2, because 5 to the -2 power would give me 1/25th, which is the same thing as 0.04. All right, let's look at C. This says log base is 1/2. Yes, you can have fractional bases of equals 8. So in other words, my base is 1/2. I'm saying 1/2 to some power has got to equal 8. Some of these, are pretty easy to do in your head. 2 to the 3rd, right, is equal to 8, but this is 1/2. So you know that you're going to have -3. 2 to the -3 power, right, would give you 8. All right, and then lastly, on this example, log, my base is 9, my number's 3. All right, so you're saying, okay, my base, what am I going to raise which exponent am I going to raise my base 9 to in order to get to 3? Of course, I know the square root of 9 is 3, right? So that means that I'm going to have to raise 9 to the 1/2 power in order to get 3, right? Okay, so that's how you simplify those. Okay, now, so take a look at the little paragraph that's underneath example 2 on page 487. It says the logarithm with base 10, I was mentioning this a little bit earlier, is called the common logarithm. All right, so the common logarithm is always base 10. And it's referred to as log without any subscript. The subscript's blank. And you're to assume that that subscript is 10. Okay, it's automatically base 10. All right, the other one, and it basically says, they're basically saying, okay, log base 10 of x is the same thing as log of x. And this is really the way that you're going to see it. And actually, that's the way you're going to see it on your calculator. Your calculator automatically has a common log key, which is base 10, and it's located right next door to the 7 key, right to the left of the 7 key. All right, and now that you've learned about the natural base e, right? That's around 2.7, blah, 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 blah. There's a logarithm that's base e, and this logarithm is used all over, for things that are having to do with nature. And that is denoted by, this is ln, and that means that it's base e, and they're saying, so basically log base e of x is the same thing as ln x. Okay, so this is base e, and if you look to the left of your 4 key, you will see the natural logarithm, base e, there. All right, so now let's look at example 3. Okay, you're going to use your calculator to do these, to just evaluate these logs. So turn on your calculator, make sure you're on the home screen, hit the log button to the left of the 7 key, put in the number 5 as in example 5, example 3a. All right, so what's the logarithm of 5? So this is base 10. So this is saying, what exponent would I raise 10 to in order to get the number 5? And the answer is 0.6989, whatever, 7. Okay, so I mean, this whole thing kind of rounds up to 0.699 technically. All right, so in other words, what this is saying is if I have 10 and I raise it to that exponent, I am going to get 5. So why don't you test that out for yourself? Okay, leave that number in your calculator. Hit the number 10, little caret to raise it to the power, and then hit second answer. So it'll pick up the answer that you get from log 5 and press enter. And you should see that, yes, this in fact is true. All right, so now we're going to do natural logarithms. Let's do example 3b. That's ln. Okay, natural log, so that's base e. That's automatically in there in the calculator that way. And so you're going to type that in. You're going to say ln to the left of the 4 button, 0.1, close your parenthesis, press enter, and what do you get? You get a negative 2.30, and I'll round this up to 3, okay? All right, so what's that saying? It's saying that if I take e, raise it to this power, I will get this number. Okay, well, let's try it. So your e key, right, is the second function above the division key. So second, and then e, caret, second, answer, press enter, and what do you get? Voila, that is equal to 0.1. Okay, notice how the exponent's negative here, right? Because you're getting a number that's less than 1. It's a fraction, right? So it's going to have a negative exponent. Okay, now let's do the last example on this page, on this video. Okay, we're going to do example 4. All right, it says the slope S of a beach is related to the average diameter d, which is in millimeters, of the sand particles on the beach by this equation. So S equals 0.159 plus 0.118 common log, okay, that's base 10 of d. And they basically want you to find the slope of the beach if the average diameter of the sand particles is 0.25 millimeters. And I guess different beaches have different sand particles and could have different slopes depending. So I'm thinking about Kitty Hawk. I mean, there's all these big dunes and stuff over there. I wonder if those beaches are different than maybe other ones that are more flat in other places. Anyway, who knows? All you're going to do is you're basically sticking this number right here and just crunching it out. Okay, so it says S equals, so go ahead in your calculator, put this in. I would start off by just calculating the logarithm of 0.25. Okay, so put that in, press enter. Then I would multiply that to 0.118, press enter. And then I would add that last step would be to add that to 0.159. And what do you get? You get 0.087, of course, and the book rounds that up to 0.09. Well, what is that? That's really 9 out of 100, right? So your rise over run, that's what they're saying. So for every 9, I don't know what's the units here, meters. So you're gonna have a rise of 9 meters to a run of 100 meters.